Good morning, class. I want to talk about the time that Robles went to Northgate. It is an AP type question, and I want to grade it as an AP question. So for this problem, there's going to be 9 points possible, which we'll talk about the grading in a bit. So let's read it. At the beginning, when Robles got in line, there were 50 customers inside the store. The initial, at time equals 0, there were 50 people already in the store. Customers. Keep that in mind. We're going to need to know that information later. F of t represents the people entering the store. This is people coming in. And I always like to label. So I'm just going to make sure that I can tell people are going to enter at that rate. And this is a rate. I'm going to enter that into my equation, into my calculator in a bit. Keep in mind that this is from time equals 0 to time equals 30. And these are customers per minute. So that is a rate, customers per minute. There's another equation here. Customers started to exit the store at a rate modeled by that. So this is when people are leaving or exit. And again, it is a rate. So this type of question, we have people coming in and we have people coming out. Two different rates, two different equations. So right now, I'm going to ask you to pause the video, take out your handy dandy calculator. I'm going to enter this into Y1 and I'm going to enter this into Y2. So this is my Y1 and this is my Y2. Again, pause and enter it, please. Okay, so there it is. I entered the Y1, I entered the Y2, so I can keep track of what I'm doing. Let me continue reading here. Part A. How many customers entered the store during the first 2 minutes? Well, to find the number of customers entering the store, I need to find a total or displacement. Now, a total net change, let's call it that. Words that we talked about before. To get a net change, I need to integrate a rate. The rate of when people coming into the store is f of t dt. So when I want to get a total change, I integrate the rate. Remember, there's people coming in. And I'm asked to do it in the first 2 minutes. So I need to be able to set up an integral, and then I'll take out my calculator. Remember, that's math 9 from 0 to 2. And let me kind of show you. To get the equation, I need to go to F4. So I'm going to alpha F4 Y1 with respect to X. And I get that number. Let me go to my paper. So this number, customers, is the total number of customers that entered the store in the first 2 minutes. We'll talk about grading in a bit. Part B. Find the derivative of f at 7. Using correct units, explain the meaning of that in the context of this problem. Now remember that the f is already a rate, and we're asking to take the derivative of a rate. So we need to be careful with our units in a bit. So I'm going to take the derivative of f evaluated at 7. I'm not going to do it by hand. I'm in the calculator section, so I'm going to go to my calculator. And let's go here. To take a derivative, I'm going to go to math 8. And that is the derivative with respect to x of my y1 evaluated at 7. Again, math 8, get that y1 and evaluate it at 7. So I got a negative number. I got negative 8.119, or I could also write negative 8.120. Remember, 3 places, no more, no less. If you round it off, it will make that into a 1.20, or I could just literally just cut off the rest and leave it as 8.119. So that's my number. That's what I got. What does that number mean? Well, at time equals 7, this is the rate at which customers entering Northgate has. Now, the rate is a negative number. The derivative is a negative number. If the derivative is a negative number, that means we're talking this has decreased by 8.120. Now we got to talk about the units, and the units are important. Reading back the problem, that rate that was given of F was customers per minute. This was the rate of F, and if I take the derivative of the derivative, we're talking customers per minute, or you could write per minute squared. Customers per minute, per minute. Part C. Is the number of customers in the store increasing or decreasing at time equal 5? So I want to know what's happening at time equal 5. Remember, some people are coming in, some people are coming out. And because I know 2 different units or 2 different equations up there, I can find f of 5 to tell me how many people, or the rate at which people are entering. I could find g of 5, that's the people coming out, and I'm going to compare them. And if I could see which one is bigger, I could tell what is happening. Are more people coming in or more people coming out? So I'm going to ask you to evaluate that f of 5 in my calculator. I could evaluate the function. I don't have to go to my table. I could. I'm not going to. I'm going to go alpha f4 and parentheses 5. And that will evaluate that equation at 5. I'll do the same thing for y2. Alpha y2 evaluated at 5. And I have that. So let's make sure we know which one is which. Y1 was the people coming in. Y2 was the people coming out. So f of 5 was 13.780. G of 5 was 11.533. So what's happening? Well, because this is bigger, the number of customers entering the store or in the store is increasing. There are more people coming in than more people coming out. So how do we write that? A couple different ways of doing it. I'm going to say g of 5 is less than f of 5, or f of 5 is greater than g of 5, same thing. The number of customers in Northgate is increasing. F of 5 is bigger than G of 5. More people coming in than coming out. Next one. How many customers are in the store at time equal 8? So at time equal 8, I can calculate how many people came in. I can calculate how many people came out. And that should give me the total. Now, there's one thing that we have to be careful with to figure out the time or to figure out the number of people at time equal 8. We also have to consider that there were 50 people in the store from the beginning. So I need to start with that 50 people in the store, and then I could integrate. I could add the number of people coming in. And I need to make sure that I keep track of the people that were leaving. So I'm going to subtract the people that were leaving from 3 to 8. Now go back and look at that G. That G is only from 3 to 30. So that's where I'm starting. The initial amount, how many people came in, how many people came out. Again, my calculator. 50 plus, I'm going to go to math 9, and I'm going to integrate from 0 to 8, my function, minus math 9 from 3 to 8, my function that I put in y2. And I'm going to get a total of that many people. So at time equal 8, that many customers in the store. 4 parts, A, B, C, D. Let's talk about the grading. 9 points possible, and I'm going to ask you to grade yourself, and it goes like back up here. Part A is for 2 points. 1 point if you wrote the integral. 1 point if you got the number. 2 points for part A. Part B, again, 2 points. 1 point if you got the number, either one. 1 point if you wrote some type of explanation about what that number means. Part C, 2 points. 1 point if you look at both of those numbers. If you evaluated the f function, if you evaluated the g function. 1 point if you wrote something down, saying that the number of customers was increasing. Part C is 3 points. You get 2 points for writing the integral. 2 points for that, including 50. If you don't have that 50, you don't get those 2 points. And then 1 point for writing that. So please grade yourself, add them up, a total of 9 points, and I'll give you the grading scale right now. Okay, here's the grading scale. If you got 8 to 9 points, that's an A. 6 to 7 points, that's a B. 3 to 5 points, that's a C. If you got 1 to 2 points, that's a D. Add them up, look at the scale, and give yourself a grade.